Thank you. See, I was told that I have to talk about how to teach power system and what to teach. I am not sure if I am very well qualified for that. So, what I will do, I will tell you what we teach or I teach here and how do we teach. Okay. So, and basically I will be discussing the course content and some tools which could be useful in teaching an undergraduate course on power systems analysis, and also a little bit about various ways in which you can make your classes more interactive and engaging. Okay. So, just to make sure that this is of interest to all of us, because I am sure you are from different backgrounds, right, not only from power systems, or you do not teach power systems only, right. So, that is the plan. Okay. And in between, if you like, you can interrupt me anytime and ask questions. Okay. This is only for half an hour, right. So, this is basically the course content that we teach in the UG courses. See, throughout this course, what we try to make sure is that, of course, when you pick a book on power system analysis, you will see a lot of mathematical stuff, analysis. The moment you say analysis, students tend to get bored. Okay. So, we always try to make it more practical oriented, or what really happens in the field. And let me tell you, students are always very interested to know what is happening in the field. Okay. The moment you give a practical example, immediately you can get their attention. Okay. So, that is one trick. When you see that people are slowly falling asleep, just try to tell them some practical fact. So, that might make them awake. So, we will start with the basic structure of power systems. We can you can tell them something about the history of a power system, how the power systems developed, starting from the earliest DC power system, how things evolved. Okay. This is just to set the context. By the way, the setting the context is very important, that you also might have experienced, right. Suddenly you come to the close, start writing equations on the board, and then you know what happens. Okay. So, setting the context in a class is very important. So, that is what we, and this is also true for any course. So, we briefly discuss what is the history of the power systems, how things evolved, where we are standing now, okay, and what is the process through which the power system has gone through worldwide, right. We talk a little bit about the Indian power systems, what is the current structure, the 5 regions, the fact that all the regions are now interconnected, we run at a single frequency. So, those relevant things we tell them. We can also refer to some websites which contain relevant information. For example, CEA website, Central Electricity Authority, it is a very informative website. Okay. Maybe we can make it a habit. Those who are teaching power systems, you can frequently visit that website. A lot of interesting information is there. Okay. Then power system is basically a very large circuit, right. Thousands and thousands of components with hundreds of kilometers of wires. Of course, we have to understand the basic differences between a electric circuit that the students are familiar with and the power system. You can possibly tell them about the physical differences or the assumptions that we take about the lumped circuit, for example, right. Those are basically the circuits which whose physical lengths are comparable with the physical lengths are much more smaller compared to the wavelength of the voltage or current that you are dealing with, right. But in a power system, that might be a comparable thing. So, it is not necessary that your KCL, KVL, etc., that will be satisfied all the time. So, those fundamental differences you can mention, but and then what we do, we of course, the students must have done their circuit fundamental courses. So, we just revise those basic concepts. Okay. Three-phase circuit is very important because almost invariably the main transmission, generation, transmission and bulk distribution facilities, they are three-phase. So, three-phase circuits the students should be comfortable with. So, we will revise the basics of three-phase circuits and basic power calculations. One important concept in this context that we have to be very, we have to make sure that the students really understand that the concept of reactive power, real power and apparent power. Okay. Unless they understand these things, they will find problems later on. Okay. So, we clarify those differences, all right. Then we move on to the important components of a power system. Okay. Power system is basically a conglomeration of a large number of components, and of course, it is not possible to discuss each and every component, right. So, we pick the ones which are most important in the sense that the components that affect the behavior of the power system in a major way. Okay. For example, the generators, the dynamics of the generators have a significant bearing, as we understand, on the overall characteristics of power systems, right. Personally, I tend to spend significant amount of time on the generators, okay, synchronous generators, their characteristics, both cylindrical rotor, salient pole rotor, what are their characteristics, capability curves and such things, and most importantly, what is their effect on the overall system performance. Okay. How do they affect the stability, for example, of the overall power system. So, that is of, you can introduce these concept little bit. Of course, later on when you do a full fledged analysis on stability, you can recall those concepts. Okay. Transformer is another very important component of a power system. We talk a little bit about transformers, equivalent circuits, and one very important concept in this context is the per unit system, right. So, we explain what is the importance of per unit system, why do we use per unit system, by the way. Of course, this is not a technical lecture. So, we have to make sure the students understand the importance of having a per unit system. Okay. So, those things we discuss. Regarding this transmission line parameter topic, we have to be a little careful, because there is a lot of mathematical analysis involved here, and the moment you start teaching a mathematically rigorous analysis, the students tend to get bored. Okay. So, this is one topic that we have to, and of course, the also this line modeling part. Okay. If you start teaching those line parameter calculations, inductance, capacitance and so on, spacings, how do we include those spacings, all right, the effect of earth on the capacitance and so on. Try not to spend too much time on these, on those mathematical things. Always try to give them the physical concepts, at least that is what I do. The danger in teaching all those analyses too much is that you may be losing their interest. Okay. That very often happens with these type of courses. Okay. One easy way out might be that you can give them some handouts, or the way I handle this part, I have some slides where these calculations are done. Of course, if you this you must also have experience. If you want to do a calculation on board, it will take half an hour. If you simply go through the slides, you can do it in 5-10 minutes. Okay. Of course, when you do that, you have to highlight the important steps. You are just avoiding writing the equations on board, which is very time consuming, and also you run the risk of losing their interests. Okay. So, you have to be very careful about or judicious about the use of boards and slides. Okay. So, whenever you see some topic which are calculation intensive, maybe you can give them slides, that will save a lot of time. Okay. So, that is what we do. Line modeling, pi model, distributed parameter models, we tell them what is the significance of those models and how those models are used in practice. You can talk a little bit about some power system simulation software. Okay. I will talk a little bit about this software, one such software which is freely available, at least the demo version. I will talk about that. Then another important concept that of course is a very vital thing, power flow computations, okay, power flow solution methods. Of course, you have to set the context once again. You have to tell them why these power flow methods are needed, what is the context, what is the difference between load flow solution or power flow solution from state estimation, which is very related topic. What is the major difference between state estimation and power flow solution? Okay. So, there are basically different tools for different purpose, right. Power flow solution basically is a planning tool. You take some hypothetical situation and then you try to analyze those situations, right. And state estimation tells you, of course, what is the current status of your system, right. The calculations, load flow Jacobian matrix, everything is very similar in both the cases. Okay. So, you have to be very clear to tell them what is the purpose of what, right. And when you do this, see what I have seen from my personal experience, the students very easily get carried away by those equations without really getting the physical concept. For example, in interviews when you ask them what are the different types of buses you consider in a power flow solution, and the ready made answer is that PV bus, PQ bus and PV bus, right, V delta bus. The next question we ask, how do you know what is the value of P in that particular bus? Nobody can answer. Okay. So, how do we do this? We have something called economic load dispatch, okay, which tells you what is the optimal value of P, and then from the control center there is an automatic load frequency control mechanism through which we set the value of P. And what about V? It is the main reason being the generators are usually equipped with automatic voltage generators. So, the terminal voltages are usually controlled. So, thereby we can control or set the value of P, so V, right. So, you have to set the physical context, what really happens in the field. What about P and Q? We get those measurements from substations. So, we know what are the values of P's and Q's, or when you are using the load flow solution to analyze a hypothetical situation, that time we have assumed certain values of P's and Q's. How do we get those values? We have something called load forecasting, right. We assume certain loading scenario, and since you have assumed that you have those values of P's and Q's, right. So, those we always have to relate to what happens in practice, okay. Then only they will really appreciate the the methodologies, right. Then we come to symmetrical faults. This is another area where the symmetrical components and unsymmetrical faults. Another area I would suggest you make use of slides, because there are a lot of calculations involved. Okay. If you start doing Z bus formation on your board, it might take 4 or 5 classes. Okay. So, you have to be carefully using the boards and slides. Of course, when you are showing slides, you have to highlight what are the important aspects, okay, what are the important steps. All I am saying is that you are saving some time in writing those equations, okay, because there are a lot of things involved here. We talk a little bit about power system protection. Of course, by the time we reach here, we have very limited number of classes left. So, we give a very short introduction to the protection issues, then little bit about the economic operation of power systems, and then finally something about the stability and control. Okay. Now, by the way, when we go through these containers, for example, the stability problems, there are misleading definitions given in many textbooks. We have to be very careful. At all stages, we have to refer to standard literature. Okay. I will give you one example. The IEEE standard says very clearly distinguishes the stability problems into angle stability, frequency stability, and voltage stability. Okay. The term dynamic stability, which is very frequently used in many textbooks, is no longer defined. Okay. We should not use those terms. Okay. So, you have to be going by the state of the art definitions. Okay. And there you can refer to latest IEEE standards and IEEE reports. Okay. IEEE, IET, IEC, okay, and also SIGRE. So, this is the overall content of this course. Any question, by the way? Yes, I am coming to that. Okay. So, these are some of the reference books. This book, by the way, I like this book, Glover and Sharma. They have in an Indian edition now. This book talks a little lot about the practical context. So, that is the beauty of this book. Okay. At each chapter, at the beginning of the chapter, it has a certain article which tells you what is happening in reality, what is happening in the field, which really sets the context. Then it goes to the actual subject matter. Okay. So, you can see, or you can consult this book. It is a very, and by the way, this book is probably the most popular book worldwide. If not in India, worldwide, this is the most popular book now. Okay. This is of course the classic book, Grengren Stevenson. If you are going through those analysis part, it is always helpful to refer to this book. Personally, I like this book most, Elgard. Okay, because this book teaches you from the conceptual point of view. It's very important. It's very easy to get lost in the set of equations, but this book introduces everything from a conceptual point of view. Okay. So, that is the reason why I like this book. This is another good book. Vadhava, of course, is another book. That's what, you know, good discussions are there. Kothari's book is also good, but somehow I feel it's, you know, I should not say that it's too much material is there. Probably it is good for exams. This is another thing. Try to pick the books which are good for conceptual clarifications, not for the books which are good for exams. Okay. That is what I do, at least. I do not know. So, these are the books usually we refer. Now, remember I talked about a simulation software. In each of these topics, you can actually demonstrate small examples by actually running in this simulation program. Okay. Now, this simulator, Powerwall simulator, the fully functional demo version is available. It is freely downloadable. I think it can simulate up to 13 bus or 14 bus, okay, system, right, and fully functional. It is very easy to use. You can learn it in 1 or 2 days. Okay. The students also can learn probably much quicker than us. They are smarter. And there are animation options. When you click the button, these arrows you see, they actually move. So, you know in which direction power is flowing. You can have different colored arrows for reactive power, real power, right. So, you can have a physical picture what is happening with the system. Generators will start rotating, okay, and you understand where the flows are taking place. Okay. It is a very user friendly software. The book by Glover and Sharma that I mentioned, it extensively uses this software. In fact, Overby was the person behind developing this Powerwall software. Okay. So, please give it a try. Okay. It's a very useful tool. You can also give them assignments. That is what I usually do. You can make different test cases, you can vary the generation, you can have different patterns of loadings, ask them to simulate, ask them to create fault and then see what happens. They can prepare a small report and submit, okay, and thereby they will learn a lot of things, okay. Because the problem in power system is that you really get an option to work on the field. Nobody allows you to touch the circuit breakers, utility will not allow you. So, the best thing that you can do is to work on a simulation software. So, that is the thing at least we can do, all right. I will talk a little bit about my teaching philosophy, or it is probably the philosophy which is accepted worldwide. So, if you see the teaching philosophy worldwide is experiencing a gradual shift in paradigm. Okay. So, in the earlier days what used to happen, immediately the instructor comes, he climbs the podium and then start delivering lectures. It is a very one way communication, okay. That is no longer valid. Okay. So, from the instruction paradigm worldwide, things are moving towards something called learning paradigm. Okay. The focus is now students, not the instructor. Okay. Instructor I am of no importance now. Okay. The focus entirely goes on the students. And for the students, it's a very, I suggest you go to this article. It's a very interesting article, okay. And just do a Google search on teaching and learning. Just teaching and learning. Do a Google search. You will find a lot of interesting material, okay. And there are a lot of things which needs to be learned in teaching and learning, okay. What usually happens over the years of experience, some people usually develop their own set of skills, mostly in an ad hoc manner, but there are structured ways of doing those things, okay. And it is a separate field of study. A lot of things are going on in this context, teaching and learning, okay. And the focus is now the students, and as far as the students are concerned, it does not matter which technique you are using. It can be anything, okay. It can be in instruction, it can be hands on training, it can be group discussion, anything. It can be, you can actually send your lectures to the students, they can study at their home, come back to the class. In the class you can only have discussions. The point is that it is a very flexible mechanism, okay. You do not have to stick to stereotype lectures. Use your common sense and do whatever you like, whatever is best for the students, whatever is working best, okay. So, that is the idea here. Few things probably you can tie, mostly in these type of courses usually you have a large number of students. Again, do a Google search, how to handle large classes. It is not easy, even for an experienced teachers also, handling large classes is not easy, okay. Very easily people sitting in the back will lose their interests, okay. The attendance will come down. Of course, there are structured ways of taking the attendance. Nowadays we have biometric system, okay. They have to give their fingerprint, okay. Of course, I never opted for those options. The very first day I tell them, if you like my class you can attend, otherwise not, okay. If you are teaching well, they will attend, as simple as that, okay. So, in a large class you can use different techniques. You can, the first thing that you have to make sure that you are actually reaching to the students. A simple technique that you can use is start walking towards the back, while that is why I like these devices, okay. You can walk around with these devices attached to you, okay. Walk around the classes, okay. And you must have figured out some people sitting at the back, they are not doing anything. Just walk towards them and then see what they are doing, okay. Give them a small tips. What are you doing? You just do it in this way, just 1 or 2 words with them, that will probably recharge them, okay. It is a very effective technique, okay. You can sometimes make smaller groups, okay, 4 or 5 benches, they can, or 8 or 9 students, they can form a group. Give them a topic, okay. They can do a group discussion and tell you what is the outcome, okay. Sometimes there are shy students who are not comfortable in asking questions. Okay. That very often happens. So, one very effective technique that you can use, you can distribute pieces of papers. You can ask the TA, that is what I do usually. I ask the TA to carry a packet of small paper sheets and they distribute throughout the class. Okay. I tell them, write your questions, there is no need to write your name, fold it, it can be anonymous, and then finally those are collected in the same packet. Okay. Nobody scared of asking, even if somebody is scared of asking a question, they can easily write it. Okay. Write it in a piece of paper, put in the box. Next class, before going to the class, you can actually go through those questions, you will find a pattern. Maybe some topic you missed giving some importance, okay, or there may be some particular area where a lot of students are finding difficulty that you may not be knowing. So, it is a very good exercise. I usually do 4 or 5 times in a course, okay, or you can do it much more frequently. So, then the next class you can discuss those questions. Okay. So, that is a very useful way to clear any doubt. All right. So, just explore, as I mentioned, teaching and learning, there are very useful techniques which can be of lot of use. Okay. At the end of any topic, I find one technique which is very useful to draw some kind of mind map. Professor Iyer mentioned that at the end. What is a mind map? You can, for example, you are teaching in electrical machines. Okay. Maybe you can just, I will take 2 minutes. So, you can classify into different types of machines: synchronous machine, induction machine, DC machine, okay, and so on, and many other different types of machines. And within this space you can probably write the machine equations, 1 or 2 very key equations. Okay. What is the relation, what are the similarities between these machines? So, the advantage here is that, see, basically there are 3 types of learners, or each of us learn by 3 different methods: audio, visual and kinesthetic. Okay. Visual is just looking at the slides. Okay. Personally, I am not a very good visual learner. Okay. Audio, lecturer talks and you listen. Okay. There is another way of learning. Again, I am a very bad audio learner. What I usually find good for me is kinesthetic. You actually do hands-on things. Okay. Hands-on can be in different ways. You can talk to your friend, group discussion. Okay. For example, if you are teaching line model, what I do, I always carry a section of cable. You can ask your local engineers or CPWD or whoever does your engineering works, take a piece of cable with you, okay, circulate that. So, they will have a feeling of how a cable looks, what are the things inside, okay, and if possible give them a small machines that might be available in your labs, okay. Of course, that somebody has to carry that. So, doing something by hand is a very effective way of learning. Okay. So, the mixture of all these things, the 3 different techniques, if you use, your teaching can be much more effective. Okay. So, there are these different techniques which you can try to make your talks more engaging, and always try to create an atmosphere of friendliness. Make sure that the students are not afraid of asking any question. Okay. Allow them to interact. That is how things work for me. You can figure out what is best for you. Okay. Just try to be honest with yourself. That is all. All right. I think that is all I have. Any question? No question? All right then. Yeah. Thank you.